In the vastness of the cosmos, a question dances through the minds of astronomers and dreamers alike. Are we alone? This inquiry has propelled mankind into an unending quest, driving our gaze to distant stars and the potential worlds that orbit them. With each passing day, our technology becomes more sophisticated, allowing us to peer deeper into the universe. It ignites a yearning within us to explore the myriad of planets beyond our solar system. As we delve into this journey, we find ourselves captivated by the remarkable discoveries of exoplanets, worlds that may harbor life, or perhaps even resemble our own Earth. Imagine this. Over the last few decades, scientists have identified thousands of these exoplanets, each one a potential chapter in the tale of life beyond Earth. As of now, more than 5,000 confirmed exoplanets lie on the planetary register. Among these, a finite few capture our imagination like no others, those that lie within the so-called Goldilocks zone. This narrow band, not too hot and not too cold, presents an intriguing possibility. The presence of liquid water, a crucial ingredient for life as we know it. Consider the nearly 10% of these identified planets that are categorized as potentially habitable. Just think about it. Each one of these worlds could hold the promise of alien life, waiting patiently in the cosmic expanse for us to unlock their secrets. As we venture further into this journey, the concept of habitability becomes multifaceted, extending beyond the mere presence of water. Factors such as atmospheric composition, surface conditions, and stellar activity paint a more complex picture of what it truly means for a planet to be suitable for life. Take a moment to visualize Kepler 452b, often referred to as Earth's cousin. This exoplanet orbits a star similar to our Sun, located roughly 1,400 light-years away. Kepler 452b sits comfortably within its star's habitable zone and boasts a size that might allow for the existence of an atmosphere. Healthy speculation has ignited among scientists. If conditions are right, could this world harbor life? The possibility tantalizes the human imagination and beckons deeper inquiry. But while Kepler 452b stands as a beacon of hope, some newly discovered exoplanets provoke even more intrigue. For instance, the TRAPPIST-1 system, a mere 40 light-years away, hosts 7 Earth-sized planets. 3 of these planets lie within the habitable zone, presenting a treasure trove of possibilities that scientists are eager to explore. Each exoplanet holds its own unique configuration, hinting at diverse landscapes, climates, and potential life forms. These worlds serve as reminders of the boundless creativity of the universe and how it continuously shapes and reshapes the conditions for life. As we continue this quest, we confront the challenges that lie ahead. The immense distances involved are enough to stretch the imagination, making the exploration of these exoplanets not just a task for today, but a calling for generations to come. With current technology, it's not feasible to visit these distant worlds. Instead, we rely on remote sensing, an intricate dance of telescopes that collects data and provides unprecedented insights into these far-off realms. Instruments like the Hubble Space Telescope and the recently launched James Webb Space Telescope allow us to gather data on their atmospheres, compositions, and potential signs of habitability, planting the seeds for future exploration. As we contemplate these possibilities, it's crucial to acknowledge the significance of astrobiology, the study of the origin, evolution, and potential distribution of life in the universe. The discoveries of exoplanets operate at the intersection of astronomy and biology. By understanding the conditions that may foster life elsewhere, we broaden our perspective on our own existence. We confront profound questions. What is life? How does it adapt? Could it flourish in environments vastly different from our own? Each inquiry enriches our understanding of our own fragile planet. This ongoing journey transcends scientific boundaries, capturing the cultural and philosophical essence of humanity. The search for life embarks on a quest that not only seeks answers, but also helps us frame our own sense of identity in the universe. As we discover more about these celestial bodies, we reflect on our place within the intricate tapestry of existence. The allure of exoplanets continues to unfold, revealing the depths of innovation and curiosity that drive human exploration. Each masterful finding brings us one step closer to understanding not just the universe, but ourselves. Perhaps one day we will find a world aglow with life, a reminder that in a cosmos of infinite possibilities, we are part of a larger story. As we push forward into the stars, we embrace the unknown, fueled by our insatiable quest for knowledge and connection. The universe, in its unfathomable vastness, invites us to dream, explore, and ultimately to discover. As we continue our journey through the cosmos, let's take a moment to delve into the intriguing world of exoplanets. But first, what exactly is an exoplanet? Simply put, an exoplanet is any planet that exists outside our solar system, orbiting a star other than the Sun. Since the first confirmed discovery of an exoplanet in 1992, astronomers have identified thousands of these distant worlds, revealing an astonishing variety of planetary systems scattered throughout our galaxy. The process of discovering exoplanets may seem like a scene from a science fiction novel, but it is grounded in rigorous scientific methods and groundbreaking technology. One prominent technique employed in this quest is known as the transit method. This method involves monitoring the brightness of a star over time. When a planet passes in front of its host star, it causes a slight temporary dimming in the star's brightness. By measuring these small dips in light, scientists can infer the size and orbital period of the planet. Another powerful technique is radial velocity, which detects the gravitational influence of an orbiting planet on its star. As a planet exerts gravitational pull, it causes its star to wobble ever so slightly. These movements create shifts in the star's light spectrum, which can be measured. By combining data from both transit and radial velocity methods, astronomers can derive a more comprehensive understanding of a planet's characteristics. As we uncover more about exoplanets, we encounter a fascinating diversity of environments. Some exoplanets are gas giants, many times larger than Jupiter, while others are rocky, similar to Earth. There are even planets made predominantly of ice, or with surfaces that reflect a dazzling array of colors. This variety raises pressing questions about the conditions that might support life. One of the most exciting aspects of exoplanet exploration is the identification of planets located in what scientists call the Goldilocks zone. This is the region around a star where conditions might be just right for liquid water to exist on the planet's surface. Not too hot and not too cold, but just right. The presence of liquid water is considered a crucial ingredient for life, making these planets prime candidates in our search for extraterrestrial beings. Notable examples of potentially habitable exoplanets include Proxima Centauri b, which orbits the nearest star to our solar system, and HS 1140b, a rocky planet that sits comfortably in its star's habitable zone. The exploration of these worlds not only stirs our imagination but also prompts scientific discussions about life in the universe. Could life exist in forms we have yet to comprehend, thriving in conditions dramatically different from our own? Understanding exoplanets also influences our view of Earth's own place in the vast universe. Each new discovery adds a piece to the puzzle of planetary formation and the likelihood of life elsewhere. By studying these remote worlds, we can compare their atmospheres, chemistry, and geological features with our own planet, helping us appreciate the delicate balance of conditions that allowed life to flourish here. As we gather more data on exoplanets and their atmospheres, we turn to specialized instruments such as the James Webb Space Telescope. Launched in late 2021, This remarkable observatory enhances our ability to analyze the atmospheres of these distant worlds. With its advanced capabilities, it can detect chemical signatures that may indicate the presence of life, such as oxygen or methane, in these exoplanetary atmospheres. However, as we move forward in our quest, we must also acknowledge the limitations of our current technology. The vast distances between stars present significant challenges, making direct exploration of these planets nearly impossible with today's spacecraft. Instead, we rely on indirect observations, using artistic imagination to envision what these far-off worlds might be like, fostering a sense of wonder about the possibilities that await. In conclusion, the study of exoplanets opens up an endless realm of questions and possibilities about life beyond Earth. Each discovery invites us to reflect on our existence and the remarkable conditions that allow life to thrive in our own little corner of the universe. As we venture deeper into the cosmos, let us embrace the profound mystery of whether we stand alone, or if somewhere out there, an echo of our existence is waiting to be discovered. The quest for exoplanets continues, illuminating our understanding of the universe and our place within it. As we embark on the fascinating journey of discovering exoplanets, it's essential to understand the techniques that have unraveled the mysteries of these distant worlds. Among the most prominent methods are the transit method and the radio velocity technique. Each approach offers unique insights into the presence and characteristics of exoplanets, slowly piecing together the intricate puzzle of our universe. The transit method is perhaps the most celebrated of these techniques. This method relies on a cosmic ballet, where the movement of a planet in front of its host star temporarily dims that star's light. Imagine shrouding a distant beacon with your hand. For a brief moment its glow wanes, and this subtle change does not go unnoticed by our precise instruments. Astronomers monitor the brightness of stars, looking for these minute fluctuations in light. Over time, even a tiny dip can suggest that a planet is orbiting a star. What makes the transit method particularly powerful is its ability not only to identify the presence of exoplanets, but also to glean essential details about their size and orbit. When a planet transits, the amount of light blocked by it can reveal its size relative to its star. A larger planet will block more light, while a smaller planet may cause only a slight dimming. This method captured public imagination with the Kepler Space Telescope, which has discovered thousands of exoplanets, many of them in the habitable zones of their stars. This tantalizing possibility ignites our curiosity about their potential to harbor life. On the other hand, the radio velocity technique employs a different approach, focusing on the gravitational tug that a planet exerts on its star. As planets orbit, they exert a force on their parent star, causing it to wobble slightly. This celestial dancing act can be detected through changes in the star's light spectrum. Imagine a car approaching and then passing you. As it approaches, the sound waves compress, raising the pitch of the noise. This is the Doppler effect, which also applies to light. When a star moves towards us, its light shifts towards the blue end of the spectrum, while a retreating star shifts towards the red. By measuring these shifts, astronomers can infer the presence of an orbiting planet and estimate its mass. This technique helps distinguish between large gaseous giants like Jupiter and smaller, rocky planets akin to Earth. The precision of radio velocity measurements has grown immensely over the years, allowing scientists to detect even the most minuscule wobbles caused by small planets. The combination of these methods brings remarkable synergy. While the transit method excels at revealing the size and orbital period of exoplanets, the radio velocity technique provides crucial data about their masses. By using both techniques together, astronomers can construct a clearer picture of a planet's composition and potential habitability. For example, several rocky exoplanets identified using these methods reside in the Goldilocks zone, where temperatures might permit the presence of liquid water, a fundamental building block for life as we know it. As we peer into the vastness of space, we encounter a myriad of challenges. The vast distances separating us from these exoplanets mean that we often face limitations in our observational capabilities. Yet, advances in technology continually enhance our ability to observe and understand these distant worlds. Instruments like the James Webb Space Telescope push the boundaries further, aiming not only to discover new exoplanets, but to analyze their atmospheres for potential signs of life. It's worth noting that while the transit and radial velocity methods dominate exoplanet discovery, they are part of a wider array of techniques being harnessed by scientists. Other methodologies include direct imaging, where astronomers capture light from exoplanets themselves, and gravitational microlensing, a technique that can detect planets around distant stars by observing the bending of light. Together, these diverse approaches create a more holistic understanding of the tapestry of planets that populate our galaxy. As we continue to refine these techniques and develop new ones, the excitement of each discovery reminds us of the infinite possibilities that lie beyond our blue planet. The quest for understanding exoplanets is about more than just finding alien worlds. It is about our insatiable thirst for knowledge and the search for our place in the cosmos. With each exoplanet we uncover, we are not only cataloging distant bodies, but also weaving a narrative about the nature of existence itself, revealing clues that may one day answer the profound question, are we alone in the universe? As we ponder these possibilities, take a moment to imagine the vast fields of stars and planets, each holding its secrets, waiting to be revealed by the curious minds of humanity. Our quest has only begun, and with every new discovery, the universe continues to enchant us. As we journey deeper into the cosmos, we often arrive at the concept of the Goldilocks zone, a term that evokes the age-old fairy tale about finding the perfect fit. In the context of astronomy, this term refers to a specific region around a star where the conditions are just right for liquid water to exist on a planet's surface. This is crucial, as water is often considered a fundamental ingredient for life as we know it. To understand the significance of the Goldilocks zone, we first need to explore what defines it. Each star emits energy in the form of light and heat, creating a habitable zone around it that varies in size and distance depending on the star's type. For instance, our Sun, a medium-sized star, has a Goldilocks zone extending roughly from about 0.95 to 1.37 astronomical units, which translates to a range of about 93 million to 200 million miles. Within this comfort zone, the temperature allows water to exist in its liquid state, not too hot, where it would evaporate, and not too cold, where it would freeze into ice. As we consider newly discovered exoplanets, the importance of their location within their respective Goldilocks zones becomes crystal clear. The Kepler Space Telescope, for instance, has been instrumental in identifying thousands of exoplanets, many of which reside in these habitable zones. Each of these discoveries adds a valuable piece to the puzzle in our search for extraterrestrial life. A striking example is Kepler 186f, an Earth-sized planet located in the habitable zone of its star, which is about 500 light-years away. The discovery of such planets invites speculation about their atmospheres and the potential for liquid water, driving scientists to investigate their characteristics further. However, the journey doesn't end with simply identifying whether a planet lies within its Goldilocks zone. The search for life requires us to delve deeper into the environmental conditions. Factors such as the planet's atmosphere, its surface pressure, and even its geology play crucial roles in determining whether it could support life. For instance, the presence of an atmosphere can protect water from evaporation and create suitable pressures for life forms. Conversely, a thin or toxic atmosphere could render a planet inhospitable, despite its ideal location in its stellar habitable zone. Moreover, we mustn't lose sight of the diversity of planetary systems out there. Exotic worlds, such as those found in the TRAPPIST-1 system, challenge our preconceived notions of what habitable environments might look like. With 7 Earth-sized planets orbiting a cooler dwarf star, 3 of these reside in the Goldilocks zone. The atmospheric compositions of these planets are still unknown, but their proximity to one another offers tantalizing opportunities for comparative exoplanetary studies. Another fascinating aspect to consider is the idea of moons as habitable worlds. Some scientists suggest that moons orbiting gas giants, like Europa or Titan within our own solar system, could offer habitable conditions beneath their icy shells. As research continues, we expand our understanding of what lies within the Goldilocks zone, realizing it may not be limited to planets alone. As we embrace this evolving narrative, we find ourselves driven by a sense of hope and curiosity. The discovery of exoplanets in their habitable zones reinforces our yearning to find life beyond Earth. It fuels our imagination and fosters a collective sense of wonder about the universe. How many other Earth-like worlds are waiting in the heavens, teeming with life forms we have yet to encounter? So as we look up into the vast expanse of the night sky, let us remember that each twinkling star embodies countless possibilities. The Goldilocks zone is not just a theoretical concept. It represents our aspirations, the dreams of countless explorers, and the boundless curiosity that drives humanity to search for answers beyond our planetary home. With every new discovery, we inch closer to unveiling the mysteries of the cosmos, igniting hope for the existence of life on worlds far beyond our own. As we journey deeper into the cosmos, let us pause to reflect on some of the most notable exoplanet discoveries that have emerged in recent years. These remarkable worlds are far more than simple dots of light. They are windows into the mysteries of our universe and potential havens for life. One such fascinating exoplanet is Proxima Centauri b, located just over 4 light-years away in the Alpha Centauri star system. Orbiting the red dwarf star Proxima Centauri, this planet resides within the habitable zone, the region where temperatures could allow liquid water to exist. Proxima Centauri b has drawn immense interest due to its proximity to Earth, as well as its Earth-like characteristics. It has a mass similar to that of our home planet, and while the star it orbits is much dimmer than our Sun, there is hope that its atmosphere may support life. However, the intense stellar flares emitted by Proxima Centauri pose challenges to habitability, potentially stripping away any atmosphere the planet may harbor. Yet still, the mere existence of this exoplanet sparks our imagination about the possibilities waiting in our cosmic backyard. Moving farther into the universe, we encounter TRAPPIST-1, an exceptional mini-system that captured the attention of astronomers and enthusiasts alike. TRAPPIST-1 is home to 7 Earth-sized planets, 3 of which lie in the habitable zone of their star. This red dwarf star, considerably smaller and cooler than our Sun, allows its planets to orbit closely, creating a complex and intriguing gravitational dance. The potential for lush, water-rich environments on TRAPPIST-1d is particularly exciting. With many of its planets potentially boasting oceans, the prospect of discovering life here feels tantalizingly close, blending hope with the excitement of exploration. In the same context, we must reflect on AHS 1140b, a super-Earth located about 40 light-years from our solar system. This rocky planet, about 1.4 times the size of Earth, is positioned optimally within the habitable zone of its star. What makes HS 1140b particularly compelling is its dense atmosphere, which scientists suspect may be rich in water vapor. The presence of an atmosphere that could support liquid water increases the chances of finding conditions suitable for life. This exoplanet serves as a prime candidate for further study, as its relative proximity offers the possibility of detailed observations by future telescopes. Then there's Kepler 186f, an extraordinary find that has been labeled as a second Earth. Orbiting a star slightly cooler than our own Sun, Kepler 186f is situated in the habitable zone, where conditions could allow for the crucial ingredient of life, liquid water. This planet is about 1.1 times the size of Earth, and preliminary analyses suggest it might have the right conditions for life to thrive. As the first validated Earth-sized exoplanet in the habitable zone of another star, Kepler 186f marks a significant milestone in our search for habitable worlds beyond our solar system. Shifting our focus to more exotic environments, we also find ourselves captivated by the discovery of WASP 121b. This gas giant, situated approximately 850 light-years away, is a prime example of a hot Jupiter exoplanet. With surface temperatures exceeding 4,000 degrees Fahrenheit, WASP 121b's atmosphere is mesmerizingly dynamic, featuring clouds of vaporized heavy metals like titanium and iron. Though it does not harbor the conditions for life as we know them, its extreme environment offers invaluable data concerning atmospheric phenomena and planetary formation. Additionally, Gliese 357d has emerged as a remarkable contender in the quest for Earth-like conditions beyond our planet. Located around 31 light-years away, this super-Earth orbits within the habitable zone of its star and is about 1.6 times the size of Earth. Gliese 357d has sparked discussion surrounding the possibilities of having an atmosphere capable of supporting life. As we study planets like this one, we inch closer to understanding not only the types of worlds that exist, but also the diversity of conditions where life might arise. These exoplanets, with their unique characteristics and varied environments, weave a complex tapestry of possibilities for habitability. Each discovery deepens our understanding of planetary systems and the conditions that foster life. Through the lens of these distant worlds, we begin to reflect not just on their existence, but on what they might teach us about our own planet and the resilience of life in the universe. In exploring these significant exoplanets, every detail becomes a clue in solving the grand puzzle of life beyond Earth. Although we have yet to find concrete evidence of extraterrestrial life, each new observation and discovery brings us one step closer to answering the age-old question: are we alone in the universe? With each exoplanet profile, we embrace the wonder of exploration, not just of the cosmos, but also of our place within it. As we venture deeper into the intriguing world of exoplanets, one of the most fascinating aspects to explore is the atmosphere surrounding these distant worlds. The atmosphere serves as both a shield and a lifeline for potential life, mediating the conditions that allow organisms to thrive. Understanding what these atmospheres are composed of can give us invaluable insights into their habitability. When astronomers detect an exoplanet, they often look for signatures that suggest the presence of certain gases in its atmosphere. This detection can happen as light from the planet's star passes through its atmosphere during a transit. By analyzing the spectrum of this light, scientists can identify the chemical constituents of the atmosphere. Imagine for a moment taking a sip of the air in a place you've never been. The composition can tell you not just about the immediate environment, but also about the life forms that might be present there. On Earth, life is inextricably tied to the atmosphere. Our air is rich in oxygen and nitrogen, essential elements for most known life. But what about exoplanets? One of the most promising indicators of habitability in an exoplanet's atmosphere is the presence of molecules like oxygen and methane. These two gases, when found together, suggest biological processes. On our planet, Oxygen is produced by photosynthetic organisms, while methane is often released by microbial life. Detecting this combination elsewhere could hint at similar processes taking place on those distant worlds. Take, for example, the intriguing case of Venus and Mars. Both are often considered sister planets to Earth due to their proximity and somewhat similar compositions. However, their atmospheres tell a different story. Venus boasts a thick atmosphere rich in carbon dioxide, creating a runaway greenhouse effect and rendering the planet incredibly hot, precluding the prospect of life as we know it. In contrast, Mars has a thin atmosphere, also primarily composed of carbon dioxide, but lacking the essential warmth to maintain liquid water at its surface. Both of these planets offer lessons in how diverse atmospheric conditions can lead to vastly different prospects for habitability. In our search for potentially habitable exoplanets, we've also come across intriguing candidates like K2-18b, detected within its star's habitable zone. This exoplanet was found to have traces of hydrogen and possibly water vapor in its atmosphere. While we cannot yet conclude that it harbors life, these signs compel us to further study its atmospheric conditions, as water is undeniably a crucial ingredient for life. Recent innovations in technology, particularly the upcoming James Webb Space Telescope, will deepen our understanding of exoplanet atmospheres. This advanced telescope has the capability to capture even more detailed spectroscopic data of distant worlds. It may unveil the presence of other life-supporting gases such as ammonia, or even explore the potential for complex organic molecules. The insights gained from these measurements can redefine our understanding of what makes a planet truly habitable. However, complexity arises when considering the planet's geology and magnetic field. The mere presence of water vapor or other key molecules does not guarantee the existence of life. The stability of a planet's atmosphere can be influenced by its geological activity and magnetic field strength, both of which play vital roles in protecting the atmosphere from solar winds. Without a magnetic shield or geological processes to recycle essential elements, even a planet with a seemingly favorable atmosphere could become inhospitable over time. Additionally, the balance of gases in an atmosphere, known as atmospheric chemistry, is crucial. For example, if we were to find an exoplanet with high levels of carbon monoxide, it may signal an environment that is not conducive to life as we understand it. On the other hand, a dynamic atmosphere, one that supports weather patterns and seasonal changes, could promote an environment ripe for evolutionary processes. There is also the concept of a biosignature, which refers to any element in the atmosphere suggestive of current or past life. Some researchers even propose looking for unusual mixtures of gases that seem out of balance. For instance, if an atmosphere is found with a significant level of oxygen, yet lacks an equally high level of methane, this could be indicative of a process that maintains that unusual state, a telltale sign of life. In summary, while the exploration of exoplanet atmospheres is still in its infancy, the data we gather will help shape our understanding of life's potential beyond Earth. With every spectrum analyzed and every gas measured, we inch closer to answering that age-old question: are we alone in the universe? Atmospheric studies stand as a beacon of hope in this quest, illuminating the intricate dance of elements that may someday reveal the existence of life among the stars. As we continue on this journey through our universe, let us remain in awe of the possibilities. For the atmosphere is both an enigma and a guide, offering clues to the myriad of worlds that dot our cosmos. Together, we share in the excitement of unraveling these mysteries, as we look to the heavens not merely to search for life, but to understand our own place within this grand tapestry of existence. As we gaze into the vastness of the cosmos, a symphony of curiosity and determination drives our exploration of exoplanets. Looking ahead, several upcoming space missions and telescopes promise to deepen our understanding of these distant worlds and answer crucial questions about habitability. Among these are missions that will push the boundaries of our technological prowess, aiming to unveil secrets hidden in the atmospheres of far-off planets, and perhaps provide clues about life beyond Earth. One of the most exciting upcoming missions is NASA's Europa Clipper, scheduled for launch in the 2020s. Although primarily focused on Jupiter's icy moon, Europa, this mission will also enhance our comprehension of the potential habitable worlds surrounding gas giants. By studying Europa's surface and subsurface ocean, scientists hope to draw parallels to exoplanets tucked away in the habitable zones of their stars. With an advanced suite of scientific instruments, Europa Clipper will investigate the moon's potential for supporting life, providing insights that could inform our understanding of other icy worlds found in distant solar systems. Meanwhile, the European Space Agency is gearing up for its own ambitious endeavor with the Ariel mission, set to launch in the mid-2020s. Ariel, short for Atmospheric Remote Sensing Infrared Exoplanet Large Survey, aims to observe the atmospheres of around 1,000 exoplanets. It will use spectroscopy to analyze light filtering through their atmospheres, identifying essential compounds such as water vapor, carbon dioxide, and methane. By characterizing the chemical compositions of these atmospheres, Ariel will help us understand the processes that govern weather patterns and climate on those planets, shedding light on their potential to harbor life. In conjunction with these missions, we look forward to advances with the Very Large Telescope in Chile. This observatory continues to push the envelope of what is possible in ground-based astronomy. With its revolutionary adaptive optics and high-resolution imaging capabilities, the Very Large Telescope allows astronomers to study the faint light of exoplanets directly. These observations have the potential to play a vital role in identifying planets suitable for further research, establishing a roadmap for future exploration. As we venture forth, the ESA's upcoming space telescope, the LUVOIR, is a highly anticipated project that promises to revolutionize our search for life in the universe. LUVOIR, or the Large Ultraviolet Optical Infrared Surveyor, aims to capture stunning images of distant planetary systems using its powerful imaging capability. By studying the light from these planets and their stars, LUVOIR will help scientists identify exoplanets in the Goldilocks zone and analyze their atmospheres in detail. Through its legacy, LUVOIR will aim to address profound questions. Are we alone? What forms might life take on these distant worlds? Furthermore, we must mention the potential impact of the Habitable Worlds Observatory, envisioned to launch in the coming decade. This observatory would focus on detecting biosignatures, chemical indicators of life, on exoplanets. Equipped with cutting-edge technologies, it will analyze the atmospheric composition of planets orbiting sun-like stars. By observing planets in the habitable zones, the observatory seeks to find signs of life that might be subtly hidden within the chemical fingerprints of their atmospheres. Let's not overlook smaller, yet equally significant, missions that continue to shape our understanding of exoplanets. The Transiting Exoplanet Survey Satellite, or TESS, has already been hard at work, scanning the nearest and brightest stars for transiting exoplanets. TESS searches for Earth-sized worlds in the habitable zone, laying the groundwork for deeper investigation through telescopes like James Webb and future observatories. As these ambitious missions prepare for takeoff, they invite us to reflect on the scope of our curiosity and the relentless human spirit that seeks answers to our most profound questions. The exploration of exoplanets is not merely an endeavor of science. It is an exploration of what it means to be human, to reach for the stars, and to wish for companionship in the silence of the universe. As we await these missions and the knowledge they promise to deliver, we remain at the edge of discovery, watching as our understanding of the universe unfolds like the petals of a flower, revealing layers of complexity and beauty. With each new exoplanet found, we take one step closer to understanding not only our place in the cosmos, but the very essence of life itself, teetering on the brink of monumental discoveries that could redefine our view of life beyond Earth. The quest continues, and the universe awaits our exploration, each new mission a beacon, guiding us into uncharted territory in the search for habitable worlds. As we turn our gaze towards the infinite expanse of the universe, a profound question emerges in our collective consciousness. Are we truly alone? The discovery of potentially habitable exoplanets has ignited a spark of curiosity within us, urging us to contemplate the possibility of life beyond Earth. Each new planet identified within the so-called Goldilocks zone invites us to reflect not just on the nature of those worlds, but also on the very essence of our existence. The notion that we might share our universe with other intelligent beings is tantalizing. It compels us to explore the philosophical implications of our solitude, or lack thereof. Imagine for a moment that within the vastness of the cosmos, there exists a planet teeming with life, akin to our own. This prospect conjures images of diverse civilizations, adapted to their unique environments, just as we have adapted to ours. Each discovery of an exoplanet is not merely a scientific achievement. It is also a doorway to asking deeper questions about the nature of life itself. Throughout history, humanity has grappled with questions about our place in the universe. Since time immemorial, philosophers, scientists, and thinkers have pondered whether life is a cosmic rarity or a common phenomenon. The discovery of Earth-sized planets within habitable zones strengthens the argument for the latter. With current estimates suggesting there may be billions of potentially habitable planets in our Milky Way galaxy alone, we find ourselves at a transformative moment in our understanding of life beyond Earth. If life does indeed flourish elsewhere in the universe, what would that mean for us? The existence of extraterrestrial civilizations would challenge our long-held beliefs about our significance in the cosmos. Would we be mere players in a grand cosmic drama? Or might we be leaders in a new chapter of interstellar relationships? Such possibilities raise profound ethical inquiries. How would we approach communication with extraterrestrial intelligence? Would we seek alliances, or would fear of the unknown inhibit our willingness to reach out? The potential for life beyond our solar system also prompts us to reflect on our own humanity. As we discover more about the environments of distant worlds, we are forced to confront the fragility of our own planet. With climate change and environmental degradation posing significant threats, the search for habitable exoplanets serves as a mirror, reflecting our responsibilities as caretakers of Earth. It highlights the urgency for us to preserve our blue planet, knowing that we may not be unique, but rather part of a larger community within the cosmos. The more we learn, the more we realize how little we know. Each finding paves the way for new lines of inquiry. With advancements in technology and the upcoming missions designed to study exoplanet atmospheres, we inch closer to answers, would unveil deeper mysteries. The question of whether life exists elsewhere urges us not only to look outward, but also to look inward, examining our own values, ethics, and philosophies around the concept of life itself. Imagine if we could one day make contact with an intelligent species. This would be a momentous event that might alter the course of human history. How would we respond to messages from another world? Would we embrace this newfound fraternity, or would we retreat in fear, uncertain of the consequences? The narratives we craft around our understanding of extraterrestrial life will shape our responses. There is much at stake. Moreover, the possibility of encountering diverse forms of life pushes the boundaries of our understanding of biology. Life as we know it is based on carbon chemistry and requires water. But could other life forms thrive under completely different conditions? This notion compels us to expand our definitions and categorizations of life, potentially reshaping the very frameworks of biology and philosophy. As we forge ahead in our quest for knowledge, the implications of these discoveries resonate deeply. Are we merely a product of chance, or is there a profound purpose to our existence? Within this ever-expanding universe, perhaps our search for life elsewhere is, at its core, a quest for understanding ourselves, a reflection of our deepest desires for connection, knowledge, and rootedness in something greater. With each exoplanet we discover, we are invited into a delicate dance between hope and humility. As we ponder the vast cosmos, we find solace in the possibilities it holds. The night sky, so rich with stars, reminds us that we are part of a grand tapestry woven with countless threads of existence. In this wondrous narrative, we begin to realize that the search for habitable worlds is not merely a pursuit of science. It is a journey of the spirit, urging us to explore our connectedness to the universe, and perhaps to each other. As we stand on the precipice of a new era in space exploration, it is essential to take a moment and reflect on the profound journey we have undertaken in our quest for habitable worlds. The universe is vast and full of mysteries, and through our collective efforts, we have unlocked some of its secrets. With thousands of exoplanets cataloged, particularly those nestled within the habitable zone, we have only begun to scratch the surface of what these distant worlds can tell us about our own. Recent advances in technology, including powerful telescopes like the James Webb Space Telescope and improved detection methods, have significantly enhanced our ability to study the atmospheres of these exoplanets. We are no longer just counting planets. We are literally peering into the very heavens to understand their potential for hosting life and the conditions that may mirror our own. The analysis of atmospheric components will help us decipher if these planets can genuinely support life, or if they too remain barren and lifeless. What makes this pursuit even more compelling is the myriad of possibilities that exist beyond our own solar system. Each newly discovered exoplanet presents a unique set of conditions and environments, from the scorching heat of super-Earths to the icy and distant orbit of cold giants. Each one may hold answers to questions we have yet to think to ask, pushing the boundaries of our understanding of life's adaptability. The implications of these discoveries are profound. If we were to find definitive signs of life on a distant world, it would alter our understanding of humanity's place in the cosmos forever. It would validate the age-old questions that have gnawed at our existence. Are we unique? Or is life a cosmic inevitability, thriving under the right conditions across various worlds? The answers to such questions could reshape our philosophy, our art, and even our sense of self. Equally fascinating is the reality that for every exoplanet we have discovered, there are potentially billions more yet to be found. The Milky Way alone harbors an estimated 100 to 400 billion stars, and many of these stars could have planets orbiting them. The potential for future discoveries is not just exciting. It is almost overwhelming. Each future finding could serve as a stepping stone deeper into the universe's hidden mysteries, leading us closer to worlds that may harbor alien life forms, or even echoes of civilizations that once thrived. Yet, as we embark on this ambitious path, we must remain humble. The vastness of the universe and the limitations of our current technologies remind us that we are still just beginning to understand the cosmic tapestry that surrounds us. Our exploration is both a scientific endeavor and a philosophical one, challenging us to confront the profound mysteries of existence. As we look toward the stars, let us maintain a sense of wonder and curiosity. Each new discovery not only enriches our knowledge, but also rekindles that childlike awe we feel when gazing up at the night sky. The universe invites us to explore, to question, and to dream of worlds unknown. We must be patient and persistent, for the most significant revelations often lie far beyond the horizon, waiting for the right tools, the right minds, and the right questions to emerge from the depths of human ingenuity. In closing, this odyssey is just beginning, and our commitment to exploring these distant realms signifies our collective yearning to know more about our place in the universe. With each exoplanet we uncover, we remind ourselves that while we may feel small in the grand cosmic scale, our thirst for knowledge is monumental. Let us continue to embrace this journey together, driven by curiosity and the hope that one day we may find companionship among the stars. If you've enjoyed this exploration into the universe's depths, consider following our channel for more fascinating content about the uncharted territories of space. And don't forget to like this video. Together, let's keep our eyes turned upward and our minds open to the wonders that await us in the cosmos.